Then dynamic evolution and structure of galaxies and with center massive binary black holes as computer simulations. My talk is a short review of our previous result in this field, started from about 1994 till present. A lot of violent phenomena take place in different places in the universe, and long time belief that galaxies dominate a single center of gravitational attraction, analogy to solar system. But observations during last 50 years show that many celestial objects have very violent, very complicated structure. And now we can think that maybe multiple center of attraction can create such structure, special attention to dominate center supermassive binary black holes. And also in 2015, Liga Observatory reported first direct observation of really binary black hole. What is confirming prediction by Einstein in general theory of relativity. Then relevance of a study of dynamics of galaxy systems with central massive binary black holes is now. Then we consider a system consisting with many particles. What is the basic method of studies by computer simulations of systems? It was started a very long time. This hydrodynamics, gravitation potential theory, stellar orbit theory, and gravitation and body problem with large N. And all in these cases, we can consider only collisionless system. But gravitation body problem was related very soon after discovering Newton gravity law. And 300 years, many very famous scientists tried to study and to get significant results by using analytical methods, but we still don't have now something what is satisfied. And when appear computers start computer eras, we study evolution of these systems using numerical calculations. This is just papers what I can show now. This is N-body tree, when triple systems and very popular, and the three-body problem from Pythagoras to Hawkins. And these three papers were published in the same year, independently, of course. And first our paper, it was published in Russian in 1966. It was translated in Russian. But for small bodies system and of more than three, first paper was by Horner, 1960. Number of particles from 4 till 25. And later, computer power was increased. In 1974, independently appears two publications with Arset and William with number of particles 500. We can know that investigation of N-body problem with large N and Tesla system it requires a lot of CPU time for large N. But if we will consider systems with small and especially an three-body problem, then we can use systematical statistical methods. And we developed representative samples of initial conditions, reveal general features of dynamics of the system, and detailed gravitation interaction. And also previous investigation system, dynamic of system and few from 4 and 500 show that in center system, three-body interactions play crucial role in central region of these areas, these systems. Previous result, first investigation applied a strict three-body problem to study the structure of galaxies, where Tumre and both Tumre brothers in 1972, Linus Aslov 1977, Walton and his colleagues from 1974. What is the general model in this case? They consider two initially two massive bodies independent, and they have parabolic, hyperbolic, or high elliptic relative motions. And they are surrounded by zero mass particles, and because this system is unstable, have a positive total energy, then particles could have only one approach with each massive body. And we consider the low initial conditions, and they get first got a very important result, basic result, that formation of bridge and tails due passages disturbed by galaxies can be produced during this process, these approaches. Now we consider our models. Here I present my colleagues in this field, co-authors in this field, Ananda Rao from India, Tanikawa from Japan, and Benedict from USA. In these models, we consider long-living center massive circular binary system, stable one. And numerous interactions of small bodies with binary component, but they don't interact with each other. We consider shells center-to-center inertia of binary, and they are located inside and outside of binary orbit. And each shell has 1,000 small particles, which are distributed uniform randomly in these shells. Initially, particles have only radial velocity with respect to central system for realization of strong interactions of bodies at the beginning. And they moved initially from center of the system. And now it is very important to note that we are not consider a model of whole system of galaxies. We study only central strong interactions of bodies. We consider different parameters, masses of heaviest component is a unit of mass. We choose another component mass from this interval. Low mass particles always the same. Initial radius from interval 0.25 to 50, and then it is particles inside, sometimes inside binary orbit, sometimes outside. and also different velocities of particles in interval from 0 till escape velocity. Of course, this is the mentioned one. And system of units, mass, distance to the semi-major X, and system of units, period of binary rotation, gravitation constant is 1. Okay, what do we carry out with this in investigations? We can consider numerical initial conditions in different parameters. So many different variants. Also dynamics of all spherical shells together and separately. Our method allows us to follow individual trajectories of particles. They close double and triple approach. Although number of considered small mass particles is about several 10 of thousands. And during evolution, we inspect time-dependent structures of models and classify numerous strong triple interactions of bodies resulting in different structure. We use method of calculation, Newtonian regularized Newtonian motions equations, and using quota by RZ at 0. All calculation carry out during 40 periods of rotation of binaries. And the total result, what we get. Because initial velocities were directed out to center in the beginning, we have system expanding. After some time, particles stop and start to move to center. And sometimes we have collapse of system. And in this time, we have a lot of small particles, close approach with heavy binary components. Often occur gravitational slingshot effect. I will a little bit later will show what is the situation. If particles initially outside binary orbit, they often quickly escape from system. Other particles captured by binary and can compile Dumbbell bar and form different kinds of structure, jets, flows, open and closed spirals and rings. Our calculation showed that obtained structures are very often to observe galaxies, structures of galaxies. What I will show you later. And symmetrical structure appear only with models with equal masses of binary components. And finally, system expanding significantly, sometimes 300 times after 40 periods of rotation of binary. Because we consider individual trajectories of particles, then we suggest dynamic explanation, how it's happened and what's going on when we obtain different structures of galaxies, structures, inner parts, different pattern structures. Particles who are initially outside of binary orbit, results of close approaches with binary. They depends on motion of these particles to relative to line on axis of binary orbit in momentum start close approach. In case of almost orthogonal motion, this is gravitational slingshot effect. These particles escape from system, and before escape, they form open expanding spirals. In alternative case, these particles captured by binary and compiled them by bars. Intermediate case, we have jets, flows, open, closed spirals, and rings. These effects are more pronounced in plane of binary orbit. And one more time, significant changes of structure often occur after gravitational screenshot effect. This is a scheme what we construct to show how what happened in order to approaches will produce different kinds of structure. This is a XY plane of binary orbit. AB masses components of binary, and see these are small particles. C0 and the initial moment of approach, and C final. I don't see this. No, this photos. C final is here. Sequence of different symbols, the same symbols is different. The sequence show flows of particles with different. One sequence show position of particles with the same final motion. The other sequence show different results. No, okay, this slide show symbols in previous figure, what I will show again. The angles and the filling circles escape, open squares injection, tick crosses and start, open close spirals, snowflake, dumbbell bar. Then like this, and so on. And oh my God, sorry, it's very sensitive. And in the left and negative quadrant shows schematically initial positions of particles with different final motions. There's a escape injection, rings and spirals, and bars. And now I show you trajectories of bodies during gravitational slingshot effect, what produce escape particles from system. A and B, this is components of binary. 0 is initial moment, and 10, this is final moment. This before triple approach and after this approach. Lines show trajectories of bodies. C is the single body, what is passed. Line of absent of binary, and is almost perpendicular. And after that, get high velocity and escape. This kind of approaches produce very sensitive changes in structure. Okay, we obtain a lot of models where what are similar to observed structures of galaxies. Here I show results for 5 galaxies. This first one, this R1, this is symmetrical spiral galaxy in constellation Ursa Majoris. This is first object of Atlas of peculiar galaxies by Halton Arp. This observed picture from Hubble Space Telescope. And this is Hmm. Do you see this kind of figure? Excuse me, sir, you hear me?
Yeah.
Yeah, we can hear you.
Do you see good this figure? See?
Yeah, we can see you.
I see
See.
only half. I can see only half.
No, we can see it fully.
Okay. Then this observed galaxy, this is our model, what I obtained. This is show dynamical evolution of some system to get some parameters, what I will show you later. There in the right, I don't see. This is a snapshot of models and 10 times, 10 snaps from initial moment to final. And next, it will show you this more detail model, what it is 6 from here. This one, the same. And these models of parameter of models. Then this is masses of all components of binaries are equal. And initial particles located out of binary orbit, the velocity is now high, and calculations are carried out during 40 periods of rotation. Next galaxy, Arc-5, Barrett's spiral galaxy, very beautiful, and constellation of Leo. Then this characterized by asymmetrical shape, spirals, but very different. Yeah, then again, this comparison observations with model galaxy, and this is dynamical evolution structure of this model. In this case, masses of binaries are different. The one we have a symmetrical structure. Then symmetrical structure will form only in case of equal mass of component of binaries. These small velocities, and also initially particles were out of binary orbit. One more. This is R22, Barrett's spiral galaxy, but it will also have asymmetry of structure. This figure shows comparison with observation, and this structure is very similar to this moment or this one. Yeah, this more detail, and this is parameter for this. Is asymmetry and much different. Next galaxy is also very beautiful, and we can compare with model. This one, and this is also this place, and parameters asymmetry, then different masses. These particles are located very close to binary orbit line and small velocities. And last galaxy, what I show you today, and this galaxy Arc-77 and constellation forms. This again symmetrical, beautiful spiral galaxy. In comparison with the result, I think it is very similar. And this one, this galaxy. And this parameter, the symmetry, this equal masses. This is out of orbit and small velocities. Okay. Now the summary. And the evolution of our model produce many structures similar to observed in nuclear galaxies, including different kinds of patterns, dumbbell, closed jet spirals, and we evaluate combination of initial conditions and initial parameters for such models. Formulated the basic dynamical processes of formation different elements. Significant change structure often occur after gravitation. Slingshot effect in center of system. And our figure show compare our models with the fifth galaxies. And also this figure show models previous and future dynamics. And the last slide show basic reference and basic papers. Different. Okay, I'm finished. Thank you very much.